Hello, everybody. Hope you guys are doing good. It's me, Mr. Athar Khalik, with the physics pages. Today, we are going to solve paper 2 for physics 0625 for February March 2025. The first question is a diagram in which we can see three forces acting on it. Two forces, 9 Newton and 1 Newton, are horizontal, whereas the third is the vertical force, that is 6 Newton. To solve these type of questions, we need to find the resultant of all the forces acting horizontal first and then vertical first. So for that case, I will start with the first step. Step 1 is I am going to solve for the horizontal forces. What are the horizontal forces? If you see, there are two horizontal forces in this object. One is to the left and other is to the right. The resultant of these two forces is 9 Newton to the right. It will be taken as positive 9.0 Newton minus, or you can say plus and minus 1.0 Newton. Why I am writing minus? Because the force on the right side, I am taking it as positive, automatically force on the left side will become negative. So sum of these forces horizontal will be 8 Newton. Now on the other side, we have one horizontal force now to the right, 8 Newton, and the other force is the vertical force or upward force, that is 6 Newton. If we combine them by head to tail rule, the 8 Newton force to the right and 6 Newton force to the upward, when I combine both of these by head to tail rule, I got this diagram, and their resultant will be toward from tail of the first vector to the head of the last vector, and this is the resultant force Fr. To find this resultant force, we have a right triangle, and we know that for every right triangle we use Pythagorean. So according to Pythagorean rule, that hypotenuse square is equal to adjacent square plus opposite square. So Pythagorean says this FR is hypotenuse square is equal to adjacent is 8 square plus 6 square. If I remove the square by applying square root, I will get FR square root of 8 square plus 6 square. It becomes 64 plus 36 100, and 100 square root gives me 10 Newton. Question number two, which row defines speed and velocity? So this question is related to the definition of the speed and the definition of the velocity. We are very well aware that what is the speed? Speed is distance covered in a unit time. Speed, we can simply say distance over time. Okay. Now, this is a scalar quantity. It does not have any direction. So you can say it is a distance covered in a time but without any direction. And when we say speed with the direction, we can call it a velocity. So speed and direction can be considered as velocity. So here in this one, the first option in the speed says distance traveled in a given direction. That cannot be our choice. Distance traveled per unit time is our right choice from here, either B or C. And on the other side of the second column, velocity is speed in a given direction or speed per unit time in B and D. So speed per unit time is wrong, speed in a given direction. So our chosen answer should be the B. Question number three is related to speed time graph, and To understand speed time graph, we can see it is time on x-axis and speed on y-axis. As we approach from origin to upward, it means speed is increasing. As we move from left to right, it means time is passing. So here at this point, we can see there is a some value of speed. So it has a speed here, and this speed is smooth with the time. It means we can say this is showing a constant speed. So this is the point where we can find a constant speed. And when we move from this point to this for the B section, we can see speed is reducing with the time. So this is slowing down or speed is reducing. So this one B is the slowing down. C, time is passing, but there is no speed because it is on the x axis. So speed is zero. So we can say it is at rest or stationary. So C, and then D again, it is the option in which it is moving forward, or it is you can just simply say that it is increasing the speed or speeding up. So here in this question, what we are going to ask, we are going to find which portion is showing that it is stationary at some traffic lights. So portion C is a point where it is considered as at rest. So I will choose C for this option. The question number 4 says acceleration of free fall on the moon has one sixth of the value on the earth. So acceleration of free fall means gravitational acceleration, or G is this one. So you can simply say we know that gravity on the earth, I am saying GE for the gravity on the earth is 9.8 Newton per kilogram, whereas on the moon we simply say this is one sixth of gravity on the earth. Okay, now on the earth, astronaut mass is measured 60 kilogram. Mass is measured 60 kilogram, which row gives the mass and the weight. First of all, I will talk about the mass. That mass does not change. It remain unchanged or same. It remains same everywhere because it is amount of substance in the body. So, which option on the Earth or on the Moon mass is same? This is, if you see, mass is 60 on the Earth throughout. They are not changing, but on the Moon, this is 60 for B or D. It means we have right choices either B or C. Now we are going to talk about the weight. We know that weight is always mass times the gravitational acceleration. So let me talk about weight on the earth first. You know that weight is equal to mass times gravitational acceleration g. So 60 times 9.8 is 588 newton. And this 588 newton in two significant figures, we can round it to 590 newton. So mass on the earth is 590 newton, and that option D is correct. So specifically we are up to the point that D option is correct, but just to have further confirmation, let us consider the weight of the object on the moon. So when we are going to find weight of the object on the moon, this boils weight on the moon, what we will get? Weight on the moon, mass on the moon, that will remain 60 times one sixth of 9.8. So it becomes 10 times 9.8 because 6 cancels 60 by 10. So this is approximately or exactly 98 newton. So it confirms that our right choice is D. Here is an interesting question about the load and extension graph. So, which point indicates the limit of proportionality? First of all, a very simple thing that we need to understand. If we have a graph of two quantities, and the graph between these two quantities is a straight line like this, we call it proportional. So this is a proportional line. So when it is a proportional line, it shows that horizontal and vertical are changing simultaneously. But if it convert into curve, so it will go to either decreasing a quantity or increasing a quantity. So here you are asked to find limit of proportionality, that where proportionality is going to change. So it's understood that this curve start from the origin and it goes straight until point A, and then it is starting to bend. So limit is A point. After this is going to bend. We have an object of mass 4 kilogram, and it has a velocity of 3 meter per second in a straight line. We are asked to find momentum. So first thing first, we need to remember that momentum was denoted by letter P. So also, if you don't use the letters, you can say momentum is always equal to mass times the speed or velocity. So you have momentum is equal to mass times velocity. Told you momentum is usually represented by P, mass by M, and velocity by V. So you can say momentum is mass times velocity. Momentum is a vector quantity, velocity is a vector quantity, both have direction. So mass is 4.0 times velocity is 3.0. So we can simplify it to 12 kilogram meter per second is the unit. So our choice should be number 6. Question number 7 is showing a cylinder with two different liquids having different densities. So a student is trying to measure the pressure at point P. This is the point P, and the other point is Q. So one is at the top of the both liquids, and other one is the bottom. So we have to remember that pressure uh, due to the liquid's depth is directly proportional. Pressure is proportional to the depth. So as you go down inside the liquid deeper, pressure increases. So we can simply say that as the pressure increases, as the deeper you go, so it will be depth increasing, pressure will increase. So this is simple scenario. Pressure and depth are proportional. But there is also another thing. Pressure and density are also proportional. So if you have two different densities, so more denser will have more pressure. So more denser will have more pressure. So here I can just show you, for example, if you have two different liquid, one liquid is less dense, so you can say this is density and this is pressure. So density is less, so pressure is less, but as density increases, pressure is relevant to that one, but more denser will have more steeper the line. So more density will show you more pressure. So here in this question we have two different liquids. This one is, the whiter part is less dense, and this is more dense. So what happens if you move this, if you try to graph this one, what we will get? We can just simply say that this is the depth and this is the pressure. So first of all, for liquid with less density, you will see a line, but when this line will change the liquid, it will change. So it will become more steeper for more dense liquid. So this shows that our perfect choice will be the option B for this one. Let us move to question number 8. We have a tennis ball with a momentum of 2.3 kilogram meter per second struck by a tennis racket. For example, this is the tennis racket and the ball is moving toward it, and when it is struck, so its initial momentum is 2.3 kilogram meter per second. Now after hitting the racket, the ball goes in reverse direction, ball goes backward. So when it is reverse, final momentum and initial momentum has the different direction. So I suppose that going toward the racket, if I take it negative, so final momentum will be positive. Now, the contact time between this one, the ball and the racket is 0.0024 second, and the force applied it. The rule says force into impact time is equal to change in momentum. So we can just simply say force into impact time is final momentum minus initial momentum. So here I can just simply say 1500 times 0.0024 is equal to our required final momentum minus negative 2.3 kilogram meter per second initial. So this is 3.6 is equal to Pf plus 2.3. So the final momentum is 3.6 minus 2.3, that is 1.3 kilogram meter per second, and it is in the direction which I just showed as a positive. So 1.3 kilogram meter per second, A is our right choice. Question number 9 is related to kinetic energy with the speed. So, first of all, the initial speed is given and energy is given 32,000. So, we know that kinetic energy Ek is always equal to half mv square. We can say kinetic energy is proportional to square of the velocity or speed. So usually we use speed because it's a scalar quantity. So we have uh, this v square as a speed. So ek is proportional to v square. So I am if I am going to double speed from 8 to 16, so double the speed can increase the kinetic energy up to double square, that gives you 4 times. So Ek is approximately 4 times the so energy stored will be 4 times the initial. So we can say that if speed was 8 meter per second, so if speed is 8 meter per second, kinetic energy was 32,000 joule. So if speed is doubled 16 meter per second two times, so kinetic energy will become 4 times, and 4 times kinetic energy will be 32,000 times 4, and it will go to 128,000 joule and approximated to 130,000 in two significant figure. Moving to question number 10. Sun is not the primary source of energy for this. We know that tidal pull is tides are created because of the uh, moon's pull. So tidal pull is tides are created because of moon as a primary source of energy, not the sun. Whereas the other wind or blowing or waves are generated because the change in temperature created by the sun, and oil that are our minerals are also have a basic source of energy, sun. Question number 11. An experiment is done to compare the rate of conduction in thermal energy in a metal and plastic. So first thing we have to remember that best conductor is of the heat is metal. So metal spoon is a good conductor of heat. So when it is a good conductor as compared to plastic, so conduction is smoother and faster. When conduction is quickly through the metal, so ice cube will melt quickly. So we can just simply say which one is the correct prediction. So prediction is ice cube would melt more quickly on the metal spoon. So our answer either may be A or B. Now go to explanation. Metal is a good conductor for A. Plastic is a good conductor. No, plastic is not a good conductor. Metal is a good conductor. So this is our option A, right choice. Question number 12. Four students determine the efficiency of the four different electrical devices. The teacher knows that one student has made a mistake. So, how teachers know that is very, very important to understand. Uh, any real world device or appliances that we use doesn't have efficiency up to 100%. So if we talk about real world situation, the efficiency is always less than 100%. Even ideal case is unreal, that is 100% efficient for us. So if you look at the options here, 12%, 36%, 78%, 102. So 102% is impossible. That's why teacher is aware that this is impossible situation. So D is the correct option. A sample of gas is sealed inside a container of fixed volume. Let's say we have this container, and this container has a piston which is fixed, it cannot move, and gas molecules are free to move, they are in random motion, but they are slow, lazy movement, lazy motion. But once you applied the temperature from outside by having fire. So what happens? The heat enters to the container. When heat enters to the container, the average kinetic energy, or you can say the total energy of the gas particles increases. That increase their motion, and they become more vigorous, more quick. So as they move fast, they hit with each other, and due to which momentum changes, and the change in momentum uh, also applies to molecules, and also they collide with the walls of container and the piston. So when these molecules hit with each other, collide with each other and the containers walls of the vessel, so the pressure is increased. So heat entering is increasing directly to the pressure, so it's not going to change the volume because it's fixed volume. So heat entered, the heat increased is actually going to do two things: either it will increase the pressure, and or it will also increase the volume. But as it is a fixed volume, so this will not happen. So heat entered will directly increase the pressure of the gas. So the best answer for this is the gas particles collide with the walls of the container more frequently, to increase the pressure. That's option A. Question number 14 is also related to heat. It's about specific heat capacity. Usually, specific heat capacity is denoted by C, and its unit is joule per kilogram per Celsius. Now, what we have energy supplied, that is 12 kilojoule, and I told you the unit that we need is joule, so 12,000 joule, and temperature increases from 20 to 45. So increase in the temperature will be 45 minus 20. So you can say 25 degrees Celsius is the increase in temperature. Whereas mass is 600 gram, and mass uh, uh, can have the unit of kilogram. So from gram to kilogram, I need to divide by 1000, so I can get 0.60 kilogram mass. Now, specific heat capacity can be calculated by C, which is equal to energy supplied. I can just say energy supplied by divided by mass times increase in temperature. So you can say temperature increase. So that C is equal to energy supplied was 12,000 joules over mass we convert in kilogram, 0.6 kilogram, and we have increase in temperature 25 degrees Celsius. So if I calculate, I get specific heat capacity is 800 joule per kilogram per Celsius rise in temperature. So option D is a perfect choice for this answer. Okay. Question number 15. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into warm surrounding. As we know that metal is a good conductor. Metal is a very good conductor of heat. So when it is a good conductor of heat, it can easily also a good absorber and good you can say of heat is also. So it's a good conductor, and also it's a good absorber or good emitter of heat. Now, when it is good absorber or good emitter, it means it can absorb heat quickly. Now, it was in the night in the cold, shady room. When it went to the warm surrounding, so it absorbs heat quickly. When heat is absorbed, temperature rises, and this can increase the internal energy. So, option A is a very good choice for this question. Number 16 is a fixed max gas contained with a sealed syringe of pressure 100 kilopascal, and a plunger is slowly moved into and pressure moved until the pressure reduces to 80 kilopascal. The final volume is this 50 cubic centimeter. The temperature does not change. So when there is no change in temperature, the pressure and volume are directly proportional, and we know an equation P1 V1 is equal to P2 V2 at constant temperature. This is called Boyle's law. According to Boyle's law, we have initial pressure P1 100, P2 80, V2 50, and we are going to find volume of the gas V1. So mathematically, I rearrange the equation and I get V1 is P2 V2 over P1. By substituting the values, we can say V1 is equal to 80 kilopascal times we have 50 cubic centimeter over we have 100 kilopascal. Usually we convert kilopascal into pascal, but here kilopascal divided by kilopascal, so it is not that important. So you have here 40 cubic centimeter, the right choice. So option B is the right choice. Yes. 17 is a diagram in which water molecules are escaping. So whenever we heat up any liquid, the molecule's internal energy increases, and the molecule on the surface that have very high energy, they can escape, and this process is called evaporation. So the process when molecule escape from the surface, it might be due to increase in the temperature, or because of the heat energy, or the surface molecule have more energy, they can jump from the surface. Question number 18 is, a hot object emit thermal radiations. The emission of radiation depend upon two objects. One is the surface area and one is the temperature. If both of them are more, thermal radiation will be more emitted. So emission of thermal radiation is directly proportional to the surface area. More surface area, more emission; more temperature, more emission. So here we need to know which of these both will reduce the rate of emission. Reduce mean if the surface area is reduced, and if the temperature of the surface is reduced. So correct option seems to be D. The frequency of the wave is doubled. So frequency is this doubled, the speed is not changing, so this is constant, speed is constant. What happened to the wavelength? So wavelength, we know that frequency and wavelength are inversely proportional. uh, Lambda is 1 over f. So if I'm going to double the frequency, so lambda will be approximately half. So this is the D option, that is it. What happens to the ultrasound? We know that ultrasounds are the sounds which are having greater than 20,000 hertz frequency, and these ultrasounds are inaudible, that we cannot see, we cannot listen these sounds because the frequency is too high that our eardrum cannot tolerate it. So these are having high, and also sound waves are longitudinal waves. So we can simply say that it has higher frequency than audible sound. We cannot hear them, and these are longitudinal waves. So option A is the right choice. Question number 21. Which statement about the image produced by the plane mirror? First of all, the question is about not. What we know is plane mirror also give us a visual image, upright image, also same sized image, and also having same distance from the mirror. So same mirror distance. It is, if the object is 2 centimeter in front of the mirror, so it will be in the back side. We see it in the same back side. Doesn't mean that the image form on the other side. No, we will see that our image is away from the mirror at 2 centimeter. So we need to know which is not true. So first option says image is real, which is impossible because image cannot be seen on the other side, image can be seen on the same side. Question number 22 says a ray of light is incident on a boundary between air and water. This is for example water, and we know that the refractive index of the water, N2 let's say, is greater than N1. N1 is the air refractive index, so it is always greater. Now air boundary between air and water, under what condition ray of light totally internally reflect? Total internal reflection is dependent on the critical angle. If the angle of incidence, this angle is greater than critical angle, and ray is passing from higher refractive index material to lower, like from water to the air, and incident angle should be greater than the critical angle. So ray initially in the air, that is impossible. Third option, yes, it should be in the water. And incident on the air boundary at any angle, no, it should be at angle higher than the critical angle. So for this one, we have option D, the right choice. Converging lens is a lens that converges all the radiation which fall on a one point, that is principal focus and the image, except one condition, that is magnifying glass condition. When object is in between principal focus and the lens, then image will be virtual. Otherwise, for the except that condition, always image is real. It is inverted upside down, and also it can be small, same sized, and even larger, depending upon where the position of the object is. If image is on the other side, then it is real. So here you can see this is the candle and its image of the candle is somewhere here. So this will be, first of all, it will be inverted, and now depend upon where is principal focus. If it is on the 2f, in between f and 2f, then it will be different, but it is for sure that this image will be real and inverted. This is 100% sure thing. Now here, which type of image will be formed? If it is on the other side, it should be real and inverted, but if it is on the same side of the lens where object is or candle is present, then it will be upright and virtual. Moving to question number 24, a negatively charged rod brought near a metal sphere. For example, this is a rod and this is a metal sphere. Metal sphere has a positive, negative charge distribution, and when it is away from it, there is no change in the charge. But when we get closer to this one, this charge metal will be get closer, so all the electrons will move away from the metal, but the protons will be at the same position. So actually the reflection is the uh, attraction is between two different charge, but here electrons are movable, protons are inside the nucleus, they cannot be moved. So we can say it is a repulsion of the electron from there. So electron in a sphere attracted, this is wrong. Electron in a sphere are repelled by the negatively charged rod. Option B is correct. EMF is defined in the term of the which quantity. We know that EMF is work done on a charge to move through it a circuit by the battery. So this work done can also be considered as energy provided by the battery to a charge to move through a circuit. So you can say energy transferred by the cell in moving a charge around the circuit. Energy transferred by the cell moving voltage, this is wrong. Power transferred, wrong. So you have option A as a correct option. A resistor R is connected to the battery of EMF having V. Current is I, power is this, time is this. We know that power is equal to energy delivered per unit time. So you can say energy is equal to power into time. We also know that power is equal to current time voltage potential difference. So if I substitute it, it will be IV into T. So here option A is the correct choice. A copper wire having length 80 centimeter and area of 0.2 millimeter square has a resistance R. The length of the copper wire cross-section area has a resistance. So what is the length we are going to find? First of all, we need to understand one thing, that the resistance is proportional to length, and resistance is inversely proportional to area. It means that if length is more, resistance is more, area is more, resistance will be less. We can say resistance, sorry, is proportional to L over A. See, if the denominator is doubled, so length should also be double to cancel it. So for me, you can simply say if you have 2a, your answer will be same if you have 2l. So this will be double. So 80 centimeter will go to 160 centimeters. So length is doubled when area is doubled to have the same resistance. So option D is the correct option. Question number 28 is saying we have four identical resistors connected in which R2, R3, R4 are connected in parallel, whereas R1 is connected to R2 in series. Now, to find the effect of the removal of R4 on the resistance, effective resistance, I need to know what is the effect of these three first. We know that the effective resistance for the parallel circuit will be equal to 1 over R1 plus 1 over R2 plus 1 over R3, R2, R3 and R4. So 1 over R effective parallel will be equal to 3 over 120. So I can say parallel circuit is giving 40 ohm resistance. So when it is 8, now this parallel circuit is going to be in series with R1. So this one is R1 and here it is the effective resistance of R parallel. So the total resistance when it is in series we just add. So R1 plus R parallel give us 160 ohm resistance when it is in. But when we are going to remove the fourth resistance, so what will happen? When fourth resistance is removed, it means our parallel resistance will be having only two resistances 120 ohm, so our resistance parallel will be equal to 120 over 2, that will be 60 ohm. So now effective resistance in the case when it is removed, the R4 is removed, it will be 120 plus 60, it is 180 ohm. So it is increased by 20 ohm. Effective resistance 180 ohm is now, initially it was 160, so it is increased by 20 ohm. Now moving to the next question. The next question number 29 is related to the similar, but we have to remember one thing, that if we have concern with the voltage and the current, as current is distributed in the branch. For example, here they are saying the voltage V1 and V2 is discussed. V2 is 1.5 volt, and also current A2 is 0.5 and A3 is 0.25. We know that the current provided by the battery passing through A1 will be divided into two portions, A2 and A3 are. So the total voltage ampere current from A1 is 0.5 plus 0.25, that is 0.75 ampere. Why? Because the battery was providing 0.5 or 7, that is distributed into 0.5 and 0.25 depending upon the resistance of the circuit. So our choices may be either C or D. Now moving to the other part, the voltages. We know that the resistances are identical here. So in the loop of current A3, it is 1.5 volt here, and for sure because resistance is same, so it would be again 1.5 volt here. So the total across this loop is 3 volt, and this loop if you see is the same as this loop. So V1 will have 3 volts. So 3 volt is this option. So option D is our right choice. Question number 30 is about the um, current induced in a wire that is placed inside the magnetic field. So if you see, whenever we have a magnetic field and a wire is pushed into the magnetic field, we can see that the current is induced. So this comes with the right hand rule. in which we need to remember one thing, that the magnetic field uh, and the direction should be perpendicular to each other, so the current will also be perpendicular to them. So magnetic field is usually our first finger. Here is the direction of the magnetic field is the first finger. Induced current, sorry, the force, we can see the current will be in the middle finger. So speed will be from the thumb. So if you say you stretch your three fingers of right hand in this way, that the first finger shows the direction of the first finger shows the direction of the magnetic field B. The middle finger shows the direction of the current induced. So the speed or the motion will be shown by the motion is from the thumb. So motion is represented by the thumb. So thumb gives us the motion. So if you stretch it in this way, so we can simply say that uh, this will be into the plane of the screen. So you can say into the plane of the screen like cross. So it is perpendicular. Yes, it is perpendicular, but it is into the plane of the paper. So we will choose option C. Moving to question number 31, there is a fixed resistor connected to the secondary coil of a step-down transformer. Step-down transformer is a transformer in which output voltage is less than input voltage, or secondary voltage is less than primary voltage. Here we have the primary voltage 240 volt, so secondary voltage here will be automatically less than primary voltage. And secondary thing, it is 100% efficient. 100% efficient mean it's an ideal transformer, and for an ideal transformer we know that power input, that is primary power, will be equal to power output. And input power, you can say uh, IPVP will be equal to ISVS. Now they are saying there is a current uh, adjusted so that the fixed resistor is decreased by 0.25 ampere. So what is the change in the current? When this current in secondary coil is decreased as a whole, so it means automatically the total power will be decreased. How? Because power is equal to I squared R. So when total power output is decreased, so power input is decreased. Power input is decreased mean input current will also be decreased. So it will be decreased by less than 0.25 ampere. Here I would like to mention one thing, that input current is decreased, primary current is decreased for sure, but it is decreased less by 0.25 ampere. How we can understand this? So to understand this thing, we know one thing, that input power is equal to output power. So input voltage is 240, whereas output voltage is less than 240. That's why current decreased by 0.25 ampere in output voltage will be more, but in primary it will be less, because 240 times lesser current will be equal to, when we have less than 240 volt times more or 0.25 ampere less current from that. So this relates to the equation IPVP is equal to ISVS. Electrical device that changes the voltage of an electrical supply from 240 to 20. It is obviously, we discuss, it is step down transformer. So we have a transformer C option here. AC generator generates the electric current or EMF when the rectangular coils move. So rectangular coil, when it moves, it has four quarters from first to fourth. So in each quarter, you have different value of the EMF induced. So for example, we move for the first quarter, so voltage or value move from O to P. The second quarter it reaches to Q. The third quarter it reaches to R. So which section of the graph is rotating three quarters? So it will start from O and it will reach until R. So OR is our uh, best option for this. Question number 34 is the uranium 92-238 decays to form thorium. So first of all, we need to know that alpha particle is helium nuclei. So you can say when it will be emitted, atomic number is decreased by 2 and mass number or nucleon number is decreased by 4. So the first reaction is you have uranium 92 238. When it is converted into thorium, so it has to release alpha particle or helium nuclei 2He4. So it will be thorium 90 to 234. So this is the first step. Second step, you have thorium 90 to 234. Now they are saying this thorium is decaying further and emitting beta particle. Beta particle are basically electrons emitted from the nucleus. Now you can say how electron can be emitted from the nucleus. If you have an atomic nucleus, you know it contains proton and it contains neutron. Whenever a neutron breaks, so neutron breaks, the atom will be having one less number of neutrons will be decreased, but it will produce a proton and electron pair. This proton and electron pair, so here the proton number will be increased by 1 and this electron will release as a form of beta particle or beta negative particle. So the total number of nucleons does not change because nucleon number is number of proton plus neutron. Neutron decreased by 1 but proton increased by 1. So sum of the proton plus neutron remains same. So when this happens, thorium is going to convert into protactinium. So this thorium is going to convert into protactinium, and this protactinium is going to be having a beta emission after beta emission. So what happens is, I told you the nucleon number is not changing, but there is a problem. The number of proton, the atomic number is increased because the number of proton are increased. So this will change into 91. So your right choice will be C. 91 to 34 will be protactinium. Now, which row shows that happen nucleus decay by emitting beta particle? We just discussed when beta particle is decayed. So nucleon number does not change, but proton number increases, and electron is emitted. So neutron changes to proton and electron is emitted. So option A is the correct option. Which precaution does not always reduce the scientist's exposure when working with the ionizing radiation? Ionizing radiations are very harmful for the person who is working inside the lab, a scientist. So whenever we have a distance increase, still it will not reduce. It will not reduce the effect. But when we are talking about radiations for longer half lives, still these are radiating. You know that half life will be more and it will take more time. So when it will take more time to decay, once its process is started, it's a spontaneous process. Once it is started, it will not always reduce the exposure. So for me, the best choice is the scientists that are only work with the source of radiation for a long time will not reduce the exposure. Number 37, a detector is placed near the radioactive isotope, records 700 counts per minute and half lifetime is 8 minutes, and background radiations are 60 counts per minute, and rate after 16 minutes. So 8 minutes is the half life, so in 16 minutes it means you have two half lives. So what are the actual number of counts when we subtract the background counts from here? So actual number of count rate is 600 counts per minute. Now 640 counts per minute after first half life, half life number 1, the count rate will be half of 640, that will change into 320 counts per minute. And after second half life, what will happen, the 320 counts will reduce to 160 counts per minute. This is the actual count rate after two half lives, that is 16 minutes. But background counts are always there when it was 700 counts, and it's also there 160. So total count that will be counted on the counter will be 160 plus 60 counts, and it gives us 220 counts per minute. So the right option for this solution is D, 220 counts. The nucleus of an isotope of nitrogen N absorbs a neutron. When it is absorbing a neutron, if then decays into the carbon, what it emits. So one, it is getting a neutron, it is bombard on the nitrogen. So it's, you can say, the atomic number is actually, neutron is changing its nucleon number, but here is no change in nucleon number. So it means that this number of neutron, that should be actually, this should be increased to y15 into 7. But what actually happens is, this is, uh, atomic number is decreased to 6, and mass number is remaining same. So it means that when this is happening, so we can say that there is a particle that is released, which is not going to increase the number of neutron or number of proton. So this bombard neutron actually extracted another particle that you can say it is a proton is being emitted somehow. So when it is emission of the proton, what will happen? The number of the atomic will decrease to 6. So this proton is released, proton is released from here, and that will also reduce the total number of nucleons in it. So from 15 to this. So this might be probably a proton that has been released from the nucleus to decrease a number of atomic number by 1, and the mass number is not going to change with it. So for me, this is the right choice. Question number 39 says a graph shows how the strength of the earth gravitational field varies as the distance from the surface of the earth increases, gravitational field strength is decreases. So here we have to check the row that has the effect on the mass and the weight of the object as it moves further away. So first thing, we know that mass doesn't change. So when mass doesn't change, either we are on the surface or we are away from the surface of the earth. So option C or D might be right choice. Now coming to the weight, we know that the weight of an object depend upon mass and the gravity. So mass is not changing, this is unchanged as we said. So it directly depend upon the gravitational strength. So it means as gravitational strength will reduce, the weight will also reduce. So it will be reduced with gravity. If gravitational strength increases, it will increase. But as we know that distance is increased, gravitational strength decreases. So the mass is unchanged, gravitational strength reduces the weight. Here is the Hubble constant, and we know that Hubble constant is always the ratio of the speed to the distance. So here in the graph we are having the speed of the different galaxies and against the distance from the earth. So we need v over d. V over d, if you see in this graph, is a straight line, is like the gradient. So to find v over d, the best way is we need to find the gradient, that is rise over run. So first thing first, rise over run, let me choose 2 points from 0 to this. So this will be our run and this will be our rise, and run is 1 into 10 to the power 25 meter, and rise is about 2.0 into 10 to the power 7 meter per second. If I substitute, I got the Hubble constant 2 into 10 to the power 7 over 1 into 10 to the power 25. So this will be 2 into 10 to the power 7 minus 25. That will go to 2 into 10 to the power negative 18. And this is Hubble constant, that is per second, because meter per second at the top and meter in the bottom, that will be cancelled, so per second. So 2 into 10 to the power negative 18 per second. Thank you so much, guys. I tried to move quickly just to make you understand. If you like my video, please subscribe my channel that I can make more videos for the exam solution for you guys. Thank you so much from Mr. Athar, and see you for the next week. Bye bye.